Welcome back. Um, we're going to get into our discussion on functional group nomenclature. And the next functional group we're going to learn is acids. Very important. There's so much acid in everything we consume. And there's just a lot of acid around us. So it's important that we understand acids. Okay. Acids must have a functional group that looks like this. Now, I will point out something. If you see that I didn't give you a formula, because I think with acids and stuff, it's easier if I just give you a structure. Okay, so I'm going to draw 1, 2, 3, 4, 5, and 6. I'm going to put this in here. I purposefully drew it this way, and then I'm going to 2, 3, 4, 5, 6, and say a metal. Okay. All right, so something that was not made clear to me when I first learned this, but I guess the teacher probably said that, but maybe was not made clear, that I could never ever get it right or in terms of naming. I'm talking, this is several years ago, okay? All right, if you think about it, this is a C. Now this itself is the acid functional group. You see C double bond O, OH, right? But the C is also part of the chain containing the remaining carbons, right? These are also carbons. So when you want to actually figure out the long chain, you don't leave out this carbon and start numbering from here. You actually start from the carbon containing the double bond O and the OH. So again, as with anything else, you start numbering from the side closer to the side containing the functional group. So it's actually 6. When I learned it, say 1994, 95, it's a really long time ago, I got the illusion that I always named it, somehow I got it pentanoic acid consistently, and the teacher marked me wrong. But I don't think it was also not made clear where exactly she numbered and all this stuff. Again, as I said, this is a dreadful topic for anybody to teach. So we now know there's 6 carbons, there's not 5. This C is part of the chain. Okay, functional groups, particularly acid, must be part of the chain. It cannot be just hanging off a chain, or you just cannot leave it out. So that's 6 carbon, so that's hexane, right? And to get the last name, or the first name, last name for this is the same, replace the E with oic acid, so hexanoic acid. Now this is the first place where the group itself is the C containing the double bond on the OH, so it's 1-hexanoic acid. Okay, it's not much different here as well. So you start putting the C. Now if you don't put the C, that seems very alienistic, but if you put the C, all of a sudden it seems to make more sense, because again the formula does say there's a C there. So again, 1, 2, 3, 4, 5, 6. So I'm going to label that 4, 5, and 6, right? So again, you can also leave it as just hexanoic acid. Why? Because you know that C is also part of the chain, but it's also part of the functional group. So these both are correct. Okay, 1-hexanoic acid, hexanoic acid, this both correct. So when I name this, I may not include the 1, okay, because I think technically they're both correct. Okay, so again, this is hexanoic acid. It's just the same as the one above, hexanoic acid. Okay, but then there's a methyl group in the 5th place, so it's 5-methyl hexanoic acid, and that's it. It's important to recognize. So let's, for another good measure, okay, 1, 2, 3, 4, double bond OOH. Say this was the compound. Again, start putting the C's, okay? That's 4 carbons. The carbon containing the double bond O is where we start numbering, so that's 4. So the long chain contains 4, so butane. right? So you chop off the E and throw in the oic acid altogether. So it's butanoic acid or 1-butanoic acid. Both are correct. Okay, I've seen both, but they're both correct. And that's how you name acids. All right. Stay tuned for one more on nitro. Okay, I'm going to reserve amines for later. All right, so stay tuned.